Hello, welcome to today's math class. How do we solve this exponential challenge? The question is 5 to the power of 3x times 5 to the power of minus 1 equal to 3 to the power of 3x times 3. What is the value of x here? So let's go on this journey. So we have solution. All right. Now the first thing we're going to do here is to rewrite this 5 to the power of minus 1 because according to the rule of indices, which says that if you have your a to the power of minus m, this is 1 all over your a to the power of the positive power. Okay, so writing this is going to give us 5 to the power of 3x times our 1 all over 5 to the power of 1, which is same thing as 5, is equals to our 3 to the power of 3x times our 3. The next thing we have to eliminate 5. And how do we do that? We multiply both sides of the expression by 5. So let's go ahead and do that. So this is going to give us 5 to the power of 3x times, let's use our normal multiplication sign here, then times 5 again. This is equal to 3 to the power of 3x times our 3 times our 5. Again, we can change this to our normal multiplication sign here. So what happened? This and this will leave the system. So we are left with our 5 to the power of 3x equal to, this side we are now left with our 3 to the power of 3x there times our 15. So the next thing we do here is to make the quantity carrying the variable to be on the left-hand side of the expression. Here we have 3 to the power of 3x. So for us to move it to this other side of the equation, we have to divide by 3 to the power of 3x. So if we divide through by 3 all over 3 to the power of 3x, then we equally divide this by 3 to the power of 3 to the power of 3x. All right. So with what we have here now, what we do next here is easy. This we go with this, right? Good. Now look at the left-hand side of the expression. They have a similar power. And according to the rule of indices again, it says that if you have your a, okay, all to the power of m all over b to the power of m, we can rewrite this as our a all over b all raised to the power of m, right? So since the powers are the same and the quantity here and these, which are the base numbers, are different, all we just need to do is just to raise everything to that same power. So rewriting this side is going to give us our 5 all over 3 all raised to the power of 3x. This is equal to, we have 15 on this side left. So how do we solve this here now? Is there any way we can manipulate the right-hand side of the equation to give us 5 all over 3? Let's see. Okay, is there any way? I will put this 45 all over 3. And if we put that 45 all over 3, that will give us what we have there. So from here, the only way out here is to take log of both sides of the equation. We could use the ln base e, or we can use our log base 10. Okay, so from here, let's take our log base 10. So let's log both sides of the equation. So this is going to give us the log of our 5 all over 3 all raised to the power of 3 to the power of x base 10. This is equal to the log of our 15. Okay, so let's continue on this side of the bird. Now let's look at this. We're going to apply a property of logarithm, which says that when you have a power of this kind, move it to this side. The law says that if you have your log, let's take p to the power of k, it says move this k backward here. So we're going to end up having here k times our log, our p. Okay, so if we apply that law, we're going to move the whole of this power back to this side of the equation. So this is going to give us our 3x times our log. Here we have 5 all over 3, then base 10. This is equal to our log. Now let's look at log 15. Log 15 can be broken down into 3 times 5. So we can rewrite this as bracket 3 times and 5. Base 10. Right? Good. Here is base 10, please. Okay. So what is the next we do here now? Now we have a multiplication sign here. There is another law in logarithm which says that if you have your log, let's take our log m times our n, then this is same thing as our log m plus log n. Remember this law? Yeah, so we can apply that here. So it's going to give us our 3x. This is x, please. Write it with 3x times our log 5 all over 3 or in base 10. This is equal to log 3, then times, all right, let's take our base 10 first rather, then plus our log 5 base 10. Easy. Okay, so what we do here now, we are looking for our x. So we have to divide through by log 5 base our 3. Okay, so if we do that, it's going to give us divided by, we'll have here log 5 base. Then is 10, then we have log 5 all over 3, then base 10. Cover this and this will leave. Here we are now left with our 3x, now be equal to, here we can equally apply what we call the division law of logarithm again. Which says that if you have your log, let's put it here, log m, then all over n, this is equal to, then it is going to give us log your m, then minus log n. Remember this law? Good, so we can apply it here. If we do that, this is going to give us log 3, then plus log 5, then all over our log our 5, then minus our log 3. Or in base 10, base 10, base 10, base 10. Okay. Now the x we are looking for still carries a constant, which is our 3. So what we do, let's divide both sides by 3, and divide this by 3 also. Right? So this leaves the system. I can start writing this expression with 5, because here we have divisible plus. So I can bring 5 here, shift 3 this way, because this one we're having 5 at the start of here, then that will give us. And again, this expression, we can change it to multiplication, then it's going to give us 1 all over 3. So we can rewrite the whole of this expression as, we can now have here, therefore our x will now be equal to 1 all over 3, then bracket, you're going to have log 5 base 10, then plus our log 3 base 10, or in bracket, all right, then all over this other side we have log 5 base 10, then minus log 3 base 10. Easy. All right, so we can get the numerical value by imputing this to our calculator to get a value from this. This will also give us a numerical value. This will give us a value. This will give us a value. So if we sum up this and we subtract this, divide the answer from here, multiply it by 1 all over 3, it's going to give you a numerical value. And if you impute it into this system, then whatever you're going to have from here and whatever you're going to have from here give you an approximate value. All right? Okay, so this brings us to the end of this math class. See you in our next class. Till then, keep winning.